Hi. We're going to be learning some logarithmic and exponential equations today. We were supposed to do section 5.4 today, but I thought this section would be a little bit easier for you guys to watch on video, and then the section 5.4 would be easier for you guys if I was there in class. So this is section 5.5, day 1. We're going to be looking at some solving logarithmic equations and exponential equations. We will be using our properties of logarithms today. So if you need to get out your little sheet to do that, make sure you have that, and make sure you have your calculator with you. We'll be needing that too sometimes. So let's get all ready for that. One of the main things you want to be thinking about when you're trying to solve a logarithmic or an exponential equation is that one of the first things we need to do is find a way to isolate the power or the log. So that's one of the big ideas, is that we want to isolate the power or the log, depending on what type of problem you're looking at. And to do that, you should be following SADMAP. Okay. So kind of think about what that means. What's the power or the log here? So if we look at 3e to the 2x plus 1 equals 5, the power here is this. Okay. Or if I look at 7 log of 2x equals 21, the log in this case would be this. We want to isolate these two things and then be able to solve from there. So let's think about how we would look at a here and how we would isolate that. So following SADMAP, we want to get rid of the 1. So 3 e to the 2x equals 4. And then we want to get rid of the 3 since it's multiplying the e. So we get e to the 2x equals 4/3. So that was the isolation step. Okay. Well, how do we solve an exponential equation? You guys just took a quiz over that. We transform it into a logarithmic equation. So the base of the power becomes the base of the log. So this becomes log base e. The answer becomes the argument. And I'm going to put that in parentheses since it's a fraction. And then the exponent becomes the solution to that question. Of course, we don't write log base e. We should be writing the natural log, ln, not in. I've heard some of you guys say. So the natural log of 4/3 equals 2x. So there is our transformation step. So we go from an exponential equation to a logarithmic equation, and notice how that gets us closer to knowing what x is. So I have one more step here. And in order to get x by itself, we need to get rid of that too. So x equals the natural log of 4/3 divided by 2. So there's our exact answer. If you notice, the problem said write all your answers in exact form. Of course, you might be kind of curious what that equals. So let's look at our calculator. So we said the natural log of 4/3. So maybe better close those parentheses and then divide it by 2. So if you think it to the nearest thousandth, that's 1.44, or sorry, 0.144. And if you really were curious and you had to check that, you always could. So 3 times e, and then we said 2 times, if we use our approximation of 0.144, and then plus 1. And we should get something really close to 5 when we do this. And I didn't, because I added 5 instead of adding 1. Good job, Mr. Baker. So let's try that again. Let's add 1 this time, not 5. Should get something close to 5. There we go. We get something close to 5. And now that's on the internet forever. All right, so there's that first example. Let's look at the next one. So again, our first thing we want to do is isolate this log. And so that's pretty easy. We want to get rid of that 7. So we're going to divide everything by 7. So we get log of 2x equals 3. Now make sure you're kind of thinking about a couple things correctly, that this 2x is what's in the log. That's the whole argument right there. And then the other thing is, what's our base of our log? Remember when we just write log, it's base 10. Okay, so there's our isolation step, that our log is now isolated. And then just like the last one, if we want to go from isolation to transformation. So how do we solve this? We go this to an exponential equation. So the base of our log is important, which is base 10. And then the answer is the exponent. So this is 10 cubed. And then the argument becomes the answer. So 10 cubed equals 2x. Of course, 10 cubed is 1,000 equals 2x. So of course x is just 500. So it went from isolating the log to transforming the log into an exponential. And then we just finished solving with simple algebra from there. And so again, if you wanted to check to make sure that was true, I can go to the calculator and see if I can do this correctly this time. So we have 7 log, and then remember the 2 and the x are both inside the parentheses, so 2, and then we said x was 500. And then this should equal 21 when I hit enter. Boom, all right, answer was right. Okay, so there's the first 2 examples. You can go on to the next video for the next set.